Okay, good morning students. Today we will discuss law of equipartition of energy. So before this class, previous class, we already discussed about the pressure of an ideal gas and the different velocities of a molecule of the gas. Now the law of equipartition is nothing but equipartition of energy is nothing but the molecule, the ideal gas is consist the kinetic energy of a particle or molecule, the kinetic energy of a molecule, of a single molecule of a gas is we defined as, so this is E translational. Okay, it is translational. Translational is nothing but it move in a straight line. So the kinetic energy, so E translational equals to, so of along x direction kinetic energy plus along y direction the kinetic energy plus along z direction of mv square z mv square. So this is equation number 1. Now for the gas is moving in random motion, so we can consider the average value. Okay, the average value of energy, the average value of energy at a thermal equilibrium at temperature capital T. The temperature is considered capital T. So the average value is taken as E translational equals to the average of mvx square plus average of mvy square plus average of along kinetic energy along z direction. Okay, the average energy is equals to 3/2 kBT. So this is discussed in kinetic in previous class, kinetic interpretation of temperature. So this is equation number 2. So the gas molecule has no preferred direction, so it moves in random motion. So then we can take this terms are along x direction, so this is half kBT, and along y direction half kBT, along z direction it is also half kBT. Total 3 terms, 1 plus 1 plus 1, 3/2 kBT. So then we can write here along x direction, so this is average of along x direction the kinetic energy equals to half kBT. Okay, along y direction of mvy square equals to half kBT, and again along z direction the kinetic energy mvz vz square equals to of kBt. Okay, so this is the average average kinetic energy of the gas molecule is of kBt. Certain energy, okay, certain energy is distributed. Okay, this of kBt, and of kBt, the total energy is distributed in thermal equilibrium is called law of equipartition of energy. So this law of equipartition of energy is explained with degrees of freedom. So what is the degrees of freedom? Here, degrees of freedom. So degrees of freedom is known as the number of velocity components. So here the number of velocity components needed to describe the motion of a molecule is called as degrees of freedom. Here, degrees of freedom. Okay, so this degrees of freedom, when the number of velocity components, so for example an atom is taken as it is moves along x direction, along y direction it's move along y direction, and also along z direction it also moves along z direction. Along x direction the velocity is vx, along y direction vy, along z direction the velocity component is vz. So like the number of velocity components needed to describe the motion of a molecule so is called the degrees of freedom. The degrees of freedom is here 3 degrees. Degrees of freedom in a space is 3 for the monoatomic molecule. So we consider a same as a monoatomic molecule. So this monoatomic molecule, so in a plane it moves two modes only, along x direction, along y direction only. So like here, so this is monoatomic molecule, it moves along x direction, it moves along y direction only. Okay, it not consist, it is a only plane, so it is moves x direction, it moves y direction. So here the degrees of freedom, here degrees of freedom, here degrees of freedom in plane, so it is 2. So in a straight line, the degrees of freedom is only 1, so it is moves along x direction only. Okay, for monoatomic, so the degrees of freedom is nothing but the number of component, the velocity component, number of velocity components describe the describe the motion of a molecule is called degrees of freedom. So here for monoatomic and diatomic, for triatomic and polyatomic, it is consist different atomic molecules is consist degrees of freedom are different here. So here this is about the degrees of freedom. The such term here, okay, so the distribution of energy is the term as the total energy as a possible energies are at a certain term is of kBT. So already we discussed the total energy is distributed in as a possible modes. The mode is of kBT. Kb is the Boltzmann constant, T is the absolute temperature. Okay, the average energy is here of kBT. Okay, of kBT. So this is as a translational or rotational, this of kBT as a translational motion or rotational motion or vibrational motion. It consists vibrational motion. So quadratic equation is consist equals to of kBT. So in equilibrium, the total energy is equally distributed in all possible energy modes with each mode has an average energy. It is equals to of kBT. Okay, so this energy is known as law of equipartition of energy. Law of equipartition of energy. Okay, this law is equipartition of energy. So this equipartition of energy is depend upon the degrees of freedom. So these degrees of freedom is we can discuss here degrees of freedom for monoatomic and diatomic and triatomic. So we can discuss here monoatomic molecule. So for example, we are consider argon. So argon gas is monoatomic molecule. So this monoatomic molecule, for example, this is monoatomic molecule. This monoatomic molecule is moves along x direction. So this is moves along y direction. So this is moves along z direction. So it is moves only translational motion. So it is not consist vibrational motion. It is not consist rotational motion. Only it moves. This argon monoatomic molecule is moves. It is moves translational motion. Translational motion. Okay, for translational motion, so that is E t equals to, so it is of, okay, m vx square plus of m vy square plus of m vz square. Okay, how many degrees of freedom? Degrees of freedom is 3. So it is consist 3 by 2 kbt. Okay, now we consider diatomic molecule. So diatomic molecule are two types here we consider. So first one, rigid rotor and non-rigid. Okay, rigid diatomic molecule. So diatomic molecule shape is a dumbbell shape. So it is like here the dumbbell shape. So it consists, so here translational motion along x direction, so along y direction, along z direction. Okay, here translational here degrees of freedom equals to 3, and again it rotate, so it is rotate about y-axis, and it is also rotate about z-axis. So then rotational degrees of freedom equals to 2 only 2 directions. So then total degrees of freedom are 5. So then the energy about translational plus E rotational equals to average of mvx square of mv square, average of mvy square plus average of mvz square plus average of, this is part of rotational motion, so I1 omega 1 square plus average of I2 omega 2 square. Okay, so this is rotational motion. So this equals to, each one is consist of kbt. So of kbt 1 2 3 4 5, so here 5 by 2 kbt. So this is diatomic molecule for rigid rotor. So again consist diatomic molecule non-rigid is nothing but, so it is consist, okay, it is here diatomic a rigid rotor, so it is fixed, okay, the atom is fixed, it is not vibrating. So non-rigid is nothing but, it is the same, the diatomic is dumbbell shape, So for example, oxygen, hydrogen, so like that, nitrogen. So these are the diatomic molecules. So these diatomic molecules it is not fixed. So then it is consist here E translational plus E rotational kinetic energy, and also it is consist vibrational. So the vibrational kinetic energy. So we can find out already E rotational, E translational equals to, it is average of kinetic energy of along x-axis, average kinetic energy of along y-axis, average kinetic energy along z-axis. And here rotational kinetic energy, average of rotational kinetic energy along y direction, and average kinetic energy along z direction. Okay, here, but we consider here it is also vibrational. So it is vibrate along y direction. So like here it is moves up and down, and it is also moves up and down, upward direction, downward direction. So it is vibrational, it is consist vibrational motion. Two atoms, okay, diatoms, two atoms are moves upward direction and downward direction. So it is consist potential energy and kinetic energy. So kinetic energy and potential energy. So now E vibrational equals to, so it is right of kinetic. So M, so it is V is nothing but displacement, the rate of change of displacement, dy by dt whole square, plus potential energy of k x square is nothing but its displacement along y direction, ky square. Okay, this term also is quadratic, this term also is quadratic equation. Okay, power 2 quadratic, any quadratic equation, the total energy is equals to of kBT. So it is also consist of kBT. So the energy is EV equals to kBT. Okay, so here equals to, here the translational and rotational is 5 by 2 kBT. So plus kBT, that equals to 7 by 2 kBT. So this is the for diatomic molecule non-rigid rotor. So it is consist translational motion and rotational motion, and also is consist vibrational along it is moves upward direction and downward direction, or to and fro direction also, it is vibrate to and fro direction also. So it is the law of equipartition of energy.